Hi, this is Alex from RF Venue. I want to ask you a question. What do you think the difference is between this dipole antenna and this one? They both look just about the same length, same size, same shape, and yet we know from experience that dipole quality varies wildly from manufacturer to manufacturer and from device to device. That's why we thought it might be a good idea to do a non-scientific test on dipole quality using a measurement called return loss. Let's head into the laboratory to find out.
Return loss is the amount of RF power lost to reflection. That is to say, if you put a given amount of power at a given frequency into an antenna, how much of that power is actually radiated out into space, and how much of it is reflected back into the line. To measure return loss, I need to use our Agilent spectrum analyzer, which lets me evaluate the return loss on a standard 50 ohm load. Let me tell you what you're looking at. The analyzer is sweeping multiple frequencies across the UHF broadcast band between 470 and 698 MHz. The return loss at each frequency is displayed compared to the 50 ohm load. The closer to 0 dB, the worse the return loss. The farther down the graph, the better. Let's measure the return loss on this white no-name dipole. So over here, this particular antenna in about the 500 MHz range is giving poor return loss that's near 0 dB. But over here, in the 600s, we're getting a better return loss. Now let's switch from this one to a generic whip antenna. As you can see, the return loss across all frequencies in this range is worse than the previous antenna, which isn't surprising. A whip is a monopole antenna, a simpler design than a dipole. Now let's measure a dipole we found on a receiver imported from Taiwan. It's actually marked with a frequency range, 624 to 694 MHz, so we expect it to have a good return loss in that range. Let's find out. Sure enough, it has a big spike right in the middle of that range. If you were using this antenna on a receiver that operated in the mid-600s, you'd be in good shape. In fact, if you were operating on the exact frequency of this spike, you might see an improvement in signal level of maybe 5 or 6 dB. Here's an antenna from a Line 6 XD75 2.4 GHz mic system. It has poor return loss between 470 and 698 MHz, which is actually what we expect. If we zoom out and change the range to 470 MHz to 3 GHz, we see a spike right on 2.4 GHz, where the antenna is designed to operate. Nice job, Line 6. So, there you go. 4 antennas, 4 very different return loss profiles. Since dipole quality can vary so much, if you lose one of the antennas off your system, don't just order a generic one off of eBay. We recommend you go back to the manufacturer and have them send you replacements so you know you're getting a perfect match. Likewise, you shouldn't be swapping dipoles between different makes and models of receivers because those antennas are likely tuned to their respective devices and device frequency ranges.